Okay, well, welcome back to Elmer Time. Today we're going to be talking about crystal radios, and I know the old timers are going to say, well, I did that way back when, and well, many people have not. Many people have not put together a simple crystal radio and have learned the basics of radio. And I still feel that crystal radios are an important learning source for those new operators. So let's get into it. This is Jeffrey, AD7LN. Welcome back to the radio room. Hello everyone, and welcome back to Elmer Time. Elmer Time number 16. So, it used to be, way back when, that when someone was interested in amateur radio, that they would get a hold of someone that's already in the hobby, well established into the hobby, so that they would have an Elmer to kind of guide them, to teach them, to get them into the hobby, to start them off. Part of that starting off would not only be introduction to different types of radio equipment, antennas, coax, meters, what have you, mathematics, but also basic electronics. And the Elmer would show that new person, introduce them to soldering and electronics basics, and possibly even introduce them to some sort of small electronics kit. Maybe a meter, a radio, a receiver, and then later on that new amateur radio enthusiast would get all this information and gain from it and become an amateur radio operator. And back then you could also purchase kits that were more in-depth into electronics, such as Heath Kit, where you could put together a complete transceiver, or a receiver and a transmitter. You could put together amplifiers. Anyway, the whole start of this is that nowadays, once an amateur radio operator becomes a licensed operator in technician class, most of these people don't have an Elmer. They haven't had any experience, or very little experience, in the electronics field. I realize that nowadays things have changed and everything is getting to be more computer oriented, and that's fine. Many modes on ham radio require some sort of computer operation, whether it's just for programming first or for running a program on a certain mode. But the very basic, the very beginning, is still radio. And many of these people that are new operators, new amateur radio operators, never got to have the initial learning that the old timers did. with the introduction to electronics and building their first crystal radio. And the feeling that it gives that person once they've built a receiver almost out of nothing, just a handful of parts, and to give that person a feeling of accomplishment, even though the radio isn't as high-tech as, say, your AM/FM portables. However, the crystal radio doesn't require power. It can run for as long as that it's hooked up to an antenna and ground. And as long as there is a AM transmitter transmitting on the AM broadcast band, the crystal radio will receive it and keep playing. It just seems to me that a crystal radio is still an object or a piece of equipment that should be introduced to all amateur radios at the beginning, amateur radio operators, excuse me, so that they also can understand radio in its more basic form. So let's get a little bit into this, crystal radios, and see where we go from there. Okay, so crystal radios. The crystal radios started out in about 1902 for communications receivers, and they were specifically designed at the start for receiving Morse code or spark gap transmitters. And that's what crystal radios were designed for to begin with. And it wasn't until about around the 1920s that there was a boom in AM broadcast stations from 520 to 1600 back then, or something like that, maybe 530. In the AM broadcast band. So receivers at that time, around 1920, were still crystal radios. And what was going on at that time was you had two options to figure out a way to receive radio. And back then, that was the newest thing. It was just as exciting as when TV first came out for them back in the 1920s. And in order to get a crystal radio, you either had to make your own through kits or pre-assembled through stores. And so there were sets in the home around the 1920s for broadcast reception, starting in the 1920s, and up until the vacuum tube was invented and used in radios, which was quite some time. And even though vacuum tubes were introduced into radios, crystal radios really never left because of educational purposes, for kit assemblers, even Boy Scouts, etc., for people to learn the basics of radio. And crystal radios are quite a strange creature, really, because they're not powered by any power source other than the actual radio wave itself coming into the radio. And the main heart of the old crystal radios used to be what's called a cat's whisker detector, which was a kind of a strange looking device. Very mechanical looking. It would be on a board or a piece of wood. This would be copper. This would be an armature with a very narrowed end to it. And on the end of the board here, there would be a piece of what's called galena. It's a lead sulfate that's actually made naturally on Earth. And you would take this galena and then you get a wire wrapped around here and a wire coming down touching the galena. And you would move this armature around to get the correct electrical contact that you would need, because this is acting as a diode or a rectifier. And since it's so basic and not, what's the word I'm looking for? It's not efficient at all. That's just how it went back then in the 1920s and the 1930s. And this was even in a store-bought form as well. Now, what's replacing this nowadays is a small diode that's made out of germanium. And the diode itself is very small. It's even smaller than that. And it is a 1N34A. It's a 1N34A germanium diode that takes the place of this cat's whisker detector that uses galena as its diode contact. You will see in many pictures in radio books, crystal radio books, online, all the different types of crystal radios, all the different types of schematics, because there are different variables, all doing the same thing, using the transmitter's radio transmission power as the power for the crystal radio itself. And some of these crystal radios don't really work that well as far as selectivity. If there are many AM radio broadcast stations in your area and you do not have a good tuning form on the radio itself, you could hear all the stations coming in at once. You're hearing them, but you're hearing them all at once if there isn't a good tuner on the crystal radio. Just to show you something here. Here is a germanium 1N34A. I don't know if you can see how small this is. but it's quite small. And it's amazing that this is basically the whole radio. This little diode is basically the whole radio. It's been that way for many years. I know nowadays there are radios on a chip that have AM, FM, shortwave, airband, RDS, single sideband, all on a chip, like the 4734s, the 4735s, but they are powered. They have to be powered by actual direct current. Crystal radios do not need any external power other than the radio wave itself. And just to show you how simple these radios are, let's take that diode again. If I were to make this, here, let's draw it this way just to show you how simple it is. Let's draw it so the diode's pointing down, just to show you something. Here's that 1N, 3N, 4. Okay. That's the whole radio. To make it work, you just need an antenna, you need a ground, and you need to be able to hear it. So some headphones, like crystal headphones or a crystal earpiece. Granted, there is no tuning here, so you will hear everything on the band. Now, a standard schematic you'll see many times for crystal radios would be like this. You got the antenna, you're going to have a coil of wire, you're going to have your ground, looking similar already, isn't it? However, to tune this coil of wire, we are going to have a variable capacitor there. We're going to put another capacitor here for matching the crystal earpiece. That's your most, right there, most important part. I forgot. There we go. And there you go. Coil, variable capacitor, your diode, 1N, 3N, 4, or cat's whisker, the capacitor for matching the earpiece, crystal phone, earphone. What are the exacts on this thing? Well, the 1N, 3N, 4. This coil here is usually paper towel tube, about 1.5 inches in diameter, cardboard with about 80 to 90 turns. Of magnet wire. And you will see online many ways on how to make these coils. This is probably going to be about a 365 picofarad cap. This will probably be what 0.001 microfarad. And then crystal earphone. Antenna, as long as you can make it outside. Ground, you probably want to ground it to some water pipes in the house, or maybe the bed frame of your bed, or something low to the ground outside. Now, is this selective? Is it as good as maybe a AM/FM portable Not quite. It does have some selectivity, but it's not quite as good as a powered portable. Can this be improved? Oh, most definitely. There are many ways of improving this. Some people go as far as removing the variable capacitor and putting some tuning areas involved. Make the antenna itself tune up and down along the coil, and also have tuning along the coil on this side as well. That will give you more selectivity. And that's just one example. There are many other examples online for different coils that have taps on them with another selector switch. You can have variable capacitors in different spots. You can have just loads of different types of crystal radio circuits. Now, just for instance, back in World War II, our troops would be out on the field and they'd want to listen to what the current information was in that area, wherever they were at, but they didn't have all these parts with them, especially a cat's whisker detector or a 1N, 3, and 4. What they would do, they would gather as much wire as they could. They made these radios called foxhole radios. And they would take a flat razor blade that they would have in their shaving kits, heat it up till it turns blue, get a pencil, scrape off some of the wood off the pencil so that the lead would be showing, and they would use that lead on the part of the pencil and run it across the different spots of the razor blade for the electrical connection to substitute for this right here, for the diode or the cat's whisker. So it would be a piece of pencil, razor blade, wire. Of course, they wouldn't have this either, but it would still work without it. It just wouldn't be as efficient. But when you're out in the field in a foxhole, you only have what you find on the way. And you will also see many examples of a foxhole radio online. It's very interesting. As I said before, all crystal radios, foxhole radios, don't use power, so as long as you connect an antenna and ground to that small circuit, you're going to be listening to whatever's in that area on an AM broadcast band. Okay, so what does this little tiny diode do? Germanium 1N34 or a cat's whisker. It takes the signal, say the radio signal, let's just say this is the radio signal that's being transmitted through the air. We'll make it fun with a little bit of color in there. Okay, let's just say that that's the radio signal that's being transmitted through the air, and your crystal radio is picking this up. Well, this little diode here, or a cat's whisker detector, it takes the signal and regulates it. It regulates the signal and then extracts the audio modulation out of the signal and transfers it to the earpiece. So it regulates it, and then it transmits just the audio form up to your earphone so that you can hear it. And that is what the diode does. Now, crystal radios have to be assembled well. The connections have to be very good because there's no power to the circuit to amplify the audio or the radio signal. All the connections have to be very good because what's the word I'm looking for? Efficiency. Yes, the efficiency level has to be at a maximum in order to be able to hear, be able to receive the signal. If you have cold solder joints, if you've got a wonky antenna that's moving around, or a ground rod in the ground that's not grounded well enough, it's going to affect the receiver itself. So efficiency is key one when building a crystal radio. Even there's only just a tiny handful of parts. If you don't get the connections well, you don't have it tuned well, if the coil has got too few coils in it, it's not going to be as efficient. How do you make a crystal radio more efficient? Well, like I just said, efficiency, good connection points, efficiency through maybe making the antenna a full half wave length for the AM broadcast band. That will help. Correct amount of coils on the coil. Yeah, I don't know why I did that part. That looks funky. Anyway, experimenting with the amount of coils on wire wraps on the coil. If you have a capacitor, in line, try different types of ratings on the picofarad capacitor. Try different air core capacitors. Another one to try would be trying different manufacturers of germanium diode. These germanium diodes are far superior to a cat's whisker detector. But that's what we used to use back in the 20s and the 30s because germanium diodes were not out yet. But now that we have them, use them because it's much easier. Now, if you want to get nostalgic, yeah, you can build a cat's whisker detector with galena in it. And they look nice. They're hard to tune, but you can get them to work. But, this is basically your circuit right here. Your most basic. And it's not the best schematic. There are better ones out there. But just starting out to build one, you will definitely hear AM broadcast signals if you have AM broadcast stations within 20 or 40 miles of your location. If you have a long enough antenna outside and a good ground. Now, a person can get very technical into this crystal radio business and make a very good example with many variables, and it will receive almost as good, maybe in some spots better, than a powered portable. I have seen some versions online that are excellent on YouTube. But efficiency is key for building a crystal radio that is not being powered by anything but the radio wave itself. So keep that in mind. What else can I say about crystal radios? So I believe that building one of these, if you've never had any practice with electronics or small circuits, this is the best way to go, because you're not going to be burning anything down, you're not going to be hurting yourself. You really don't need to even solder if you want to look up some of these crystal radio how to do it videos on YouTube. You can see that the old styles were just the contacts were just put together, and there'd be a washer and a screw into wood, and that would be the old electrical contacts that used to be made for old crystal radios back in the 20s and 30s, and they worked just fine for that. Now that we have a 1N, 3N, 4 crystal, or excuse me, diode, it's a far superior receive with that diode than it is with a crystal, or excuse me, a galena whisker detector. So, starting out, building one of these gives you a sense of the basics, getting it to work, sense of accomplishment, and it's fun. It's short, it's easy, it's quick, it's very inexpensive to get the parts together to make one. Just a basic one. You can go overboard and start making the frilly ones that really receive well, and put a lot of time and effort into it. And there are people that do that for a hobby, and that's great. I believe that those people that are doing that as a hobby are getting farther and fewer between, and I'd like to see that the tradition still be kept up, because it is interesting and fun. So with that, I'll see you in the next video. Take care. This is Alpha Delta 7 Lima November on Elmer Time, and I'll catch you guys later. Thanks.